Welcome back. Let's read this.
Lockheed Martin SR-72. Not to be confused with the fictional aircraft from Top Gun, Maverick. The Lockheed Martin SR-72, colloquially referred to as Son of Blackbird, is an American hypersonic UAV concept intended for intelligence, surveillance and reconnaissance, ISR, proposed privately in 2013 by Lockheed Martin as a successor to the retired Lockheed SR-71 Blackbird. In 2018, company executives said an SR-72 test vehicle could fly by 2025 and enter service in the 2030s. Design and development, edit. Background and early work, edit. The SR-71 Blackbird was retired by the United States Air Force in 1998, eliminating a unique and useful intelligence, surveillance and reconnaissance, ISR, capability. Though most fifth-generation jet fighters and projected drones intended to operate in enemy airspace incorporated anti-radar stealth technologies, some came to believe that the growth of anti-access forward/area denial tactics and counter-stealth technologies meant that speed, not stealth, was the most promising approach to penetrating protected airspace. The first unconfirmed reports about the SR-72 appeared in 2007, when various sources disclosed that Lockheed Martin was developing an airplane able to fly 6 times the speed of sound or Mach 6, 4,000 miles per hour, 6,400 kilometers per hour, 3,500 km, for the Air Force. Lockheed Martin's Skunk Works development work on the SR-72 was first published by Aviation Week and Space Technology on the 1st of November, 2013. Public attention to the news was large enough to overwhelm the Aviation Week servers. To attain its design speeds, Lockheed Martin had been collaborating with Aerojet Rocketdyne since 2006 on an appropriate engine. The company has been developing the system from the scramjet-powered HTV-3X, which was cancelled in 2008. The SR-72 is envisioned with an air-breathing hypersonic propulsion system that has the ability to accelerate from standstill to Mach 6 using the same engine, making it about twice as fast as the SR-71. The challenge was to design an engine to handle the flight regimes of subsonic, supersonic, and hypersonic speeds. Using turbine compression, turbojet engines can work at 0 speed and usually perform best up to Mach 2.2. Ramjets, using aerodynamic compression with subsonic combustion, perform poorly under Mach 0.5, are most efficient around Mach 3, and can go up to around Mach 6. The SR-71's specially designed engines converted to low-speed ramjets by redirecting the airflow around the core and into the afterburner for speeds greater than Mach 2.5. Finally, scramjets with supersonic combustion cover the range of high supersonic to hypersonic speeds. The SR-72 was to use a turbine-based combined cycle, TBCC, system to use a turbine engine at low speeds and a scramjet engine at high speeds. The turbine and ramjet engines share common inlet and nozzle, but with separate airflow paths. At speeds of Mach 5 and above, aerodynamic heating creates temperatures hot enough to melt conventional metallic airframes, so engineers are considering composites such as high-performance carbon, ceramic, and metal mixes for fabrication of critical components. Such composites have been used in intercontinental ballistic missiles and the retired Space Shuttle. As of May 2015, the SR-72 was envisioned as an ISR and strike platform, but no payloads were specified, likely because current payloads would be insufficient on an aircraft flying at Mach 6 up to 80,000 feet. 24,400 m, high requiring hundreds of miles to turn. New sensors and weapons would likely have to be created specifically to operate at such speeds. In November 2013, construction of an optionally piloted scaled demonstrator was planned to start in 2018. The demonstrator was to be about 60 feet, 18 m, long, about the size of a Lockheed Martin F-22 Raptor, and powered by one full-scale engine to fly for several minutes at Mach 6. SR-72 flight testing was planned to follow the timeline for the hypersonic high-speed strike weapon. The SR-72 would be similar in size to the SR-71 at over 100 feet, 30 m, long and have the same range, with entry into service by 2030. It follows the U.S. Air Force's hypersonic roadmap for developing a hypersonic strike weapon by 2020, and a penetrating ISR aircraft by 2030. At the time of the concept's unveiling, Lockheed Martin had engaged in talks with government officials, but has not secured funding for the demonstrator or engine. On the 13th of November, 2013, Air Force Chief of Staff General Mark Welsh revealed that the service was interested in the SR-72's hypersonic capabilities, but had not spoken with Lockheed Martin about the aircraft. Its high speed appeals to the service to reduce the time an adversary would have to react to an operation. They were pursuing hypersonic technology, but do not yet have the material ability to construct a full-size plane like the uncrewed SR-72. The SR-72 was unveiled amid sequestration budget cuts that required the Air Force to balance capability, capacity, and mission readiness. By the mid-2020s, it was believed, foreign countries will produce and export advanced aerial technologies that could end up in battle spaces against the US. This drives the Air Force to further develop new systems, including hypersonic, to replace outclassed existing systems. In 2013, it was reported that the Air Force would decline to fund the SR-72 program, choosing instead to develop the Northrop Grumman RQ-180 stealth UAV to perform the task of conducting ISR missions in contested airspace. The RQ-180 was expected to be cheaper, faster, and less complex to design and manufacture. 2014 NASA contracts, edit. In December 2014, NASA awarded Lockheed Martin a contract to study the feasibility of building the SR-72's propulsion system using existing turbine engine technologies. The $892,292 $1.13 million in 2023 contract funds a design study to determine the viability of a TBCC propulsion system by combining one of several current turbine engines, with a very low Mach ignition dual-mode ramjet, DMRJ. NASA previously funded a Lockheed Martin study that found speeds up to Mach 7 could be achieved with a dual-mode engine combining turbine and ramjet technologies. The problem with hypersonic propulsion has always been the gap between the highest speed capabilities of a turbojet, from around Mach 2.2 to the lowest speed of a scramjet at Mach 4. Typical turbine engines cannot achieve high enough speeds for a scramjet to take over and continue accelerating. The NASA Lockheed Martin study is looking at the possibility of a higher speed turbine engine or a scramjet that can function in a turbine engine's slower flight envelope. The DARPA HTV-3X had demonstrated a low-speed ramjet, dual-mode ramjet, that could operate below Mach 3. Existing turbofan engines powering jet fighters and other experimental designs are being considered for modification. If the study is successful, NASA will fund a demonstrator to test the DMRJ in a flight research vehicle. Aerojet Rocketdyne was awarded a $1,099,916 contract by NASA's Glenn Research Center on the 15th of December, 2014 during mode transition. The two firms were reported to be collaborating on turbine-based combined cycle, TBCC, propulsion system, with plans to begin developing the SR-72 hypersonic demonstrator in 2018, with the first flight expected in 2023. In March 2016, Lockheed Martin CEO Hewson said that the company was on the verge of a technological breakthrough that would allow its conceptual SR-72 hypersonic plane to reach Mach 6. She said a hypersonic demonstrator aircraft the size of an F-22 stealth fighter could be built for less than $1 billion. 2017 to present, edit. In June 2017, Lockheed Martin announced that the SR-72 would be in development by the early 2020s, with top speed in excess of Mach 6. Executive Vice President Rob Weiss said, "We've been saying hypersonics are 2 years away for the last 20 years. But all I can say is the technology is mature and we, along with DARPA and the services, are working hard to get that capability into the hands of our warfighters as soon as possible." In January 2018, Lockheed Vice President Jack O'Banion gave a presentation that credited the advancements in additive manufacturing and computer modeling, stating that it would not have been possible to make the airplane 5 years ago and that 3D printing allowed a cooling system to be embedded in the engine. In February 2018, Orlando Carvalho, Executive Vice President of Aeronautics at Lockheed Martin, pushed back on reports of the SR-72's development, saying that no SR-72 had been produced. He also said that hypersonic research is fueling weapons development. Eventually, as that technology is matured, it could ultimately enable the development of a reusable vehicle. Prior to this we may have referred to it as like an SR-72, but now the terminology of choice is reusable vehicle, he said. In November 2018, Lockheed Martin said that a prototype of the SR-72 was scheduled to fly by 2025. In addition, the company stated that the aircraft is to be equipped to fire hypersonic missiles. The SR-72 could enter service in the 2030s. See also, edit. 1 Aurora, aircraft. 2 Boeing X-51. 3 DARPA Falcon project. 4 Northrop Grumman RQ-180. 5 Prompt Global Strike. 6 Reaction Engine Scimitar. 7 Top Gun, Maverick 2022 film in which a Dark Star aircraft was based on the SR-72 and partially designed by Lockheed Martin engineers. 8 Tupolev Tu-360. References, edit.